Welcome to this video on applied electricity. We're going to be solving questions on KCL and KVL. So as you can see, this is a circuit and it has current all over and also resistance all over. So we are to use KCL to solve this circuit. Use KCL to solve this circuit. So that means we are going to be determining the voltage. We have to calculate the voltage across all these resistors. So firstly, the first step to take is that we label our nodes, and we've done that. This is a node here. Is a node. A node is where two or more circuit elements pass through. So this is a node here. This is a junction actually, because it's already three, because one is coming either leaving or entering. This one is also coming either leaving or entering. This one is also coming. So this is a junction. This is another junction. So but here we identify it as a node because we want to use it to solve something. So now this is node 3. You are now going to be taking those nodes one by one, and you'll be using the law of KCL that says the algebraic sum of currents is equals to 0, or current entering a node must be the same thing as current leaving the node. You all know that. So current, either you say summation of current in is equals to summation of current out, and also summation of current is equals to 0. So if you bring this one here to change to minus, if it's plus before, then you equate it to 0. So let's just start like that. You have node 3. For node 3, this I is entering this node. This one is also entering. So you have I plus I1. Then this I2 is leaving this node. So it will be minus. If it's on the other side, if you bring it inside, it will become minus. So it will be, for the one leaving, it will be minus I2, then is equals to 0. That's for node 3. Let's check for node 2. Node 2. What's happening here? All the currents are entering this node. Everything are entering, so everything will be equals to 0 on the same side, all positive. So you have I2 plus I3 plus I4 is equals to 0. So that's for node 2. Then you have for node 1. So what's happening in node 1? I4 is leaving node 1. This current is leaving. Then this one is entering node 1. Remember I said this point is the node. This I4 is leaving. So for node 1, we have I4. I4 is leaving, right? So that should be minus I4, then plus I5, because I5 is entering, is equals to 0. So you now pick this node one after the other and calculate using the Ohm's law. So we know Ohm's law now, V is equals to IR. So if V is equals to IR, what will be I? No, we have only I here, so our I will be what? V over R. So we are going to be calculating the V over R. This V over R is what we are going to be using to represent this I according to what is in the node here. So let's go. So for node 3, I here, for node 3, I here doesn't have any voltage or resistor that is applying to. So you just have to put that I there. Then this I1, look at this I1 here. You are now going to look at how it is structured. It has a resistance. This is the line of the node here. We are dealing with this I1. This is the current flowing through this resistor. This I1 is the current flowing through this resistor in this direction. So when you take this I1 here, what will be the volts? The volts will be, the 0 is here, is from ground level. So it will be 0 minus V3 over this R1. Do we get? So you are targeting the line of the way the current is flowing. That's what you are targeting. So what would that be? That would be plus, don't forget the plus into brackets 0 minus V3 over R1. That's for that. Then minus our I2 this is the current, it's flowing like this. So look at the direction. You pick this V3 minus V2 over R2. For I2, it will be into bracket V3 over V2 minus R2 is equals to 0. Should we simplify that? Let's simplify it further. So it will be, we have if this I come here, so this I will later come here, so let's just deal with this first. We have minus V3 over R1 plus V3 over R2 minus minus will give us plus. So that minus V2 over R2 is equals to minus I. We are still going to be given I in the question. So for this now, if you have anything we can factorize, yes, we have V3. So you can factorize that one in one place. We have V3 into brackets minus 1 over R1 rather, then plus 1 over R2. So you close your brackets, then you have plus 2 plus V2 into brackets 1 over R2. That one is equals to what? Minus I. So you can see that. So when you want to pick V3, you just pick this for the matrix and pick this also for the matrix. Do you get? So let's take for node 2 now. For node 2, I2. Our I2, you know I said the other time, is going like this. So you have V3 minus V2 over R2 for the I2 for the current 2. So let's do that again. V3 minus V2 over R2 plus I3. Where is I3? This is I3 here. So it will be V0 minus V2 over R3 for the current flowing through this I3. It will be V0. No, 0 rather. 0 minus V2 over R3. That's down. Let's check for I4. I4 is flowing back like this. So it's flowing back. That means we are taking our direction from here. So it will be V1 minus V2 over R4. So remember your plus. The V1 minus V2 over R4. Do you get? So close the brackets. Are we following? Yes. So close the brackets and equate it to 0. So let's simplify this one also. Remember when we simplify this answer we got for this here. For node 3. I'm still going to rub off the board, but we'll copy it in another place when we want to use it. So for this one, let's simplify. We have V3R2 minus, we are separating them now. V2R2 plus, this plus and minus is minus. I know 0 minus V2 will be minus V2. So plus and minus will be minus minus V2 over R3 plus V1 over R4. Then plus and minus is what? Minus. So that's minus V2 over R4 is equals to 0. So what can we factorize here? We have 3V2. So we can bring V2 to one place. Let's first write our V1. V1 will be 1 over R4, right? So V2 is minus V2 into bracket 1 over R2. I've gotten V2 here. So, no. V2 has 3, right? So we have to bring it out. So if you are using minus outside, that means minus and minus is plus. If you want to write inside, it will be plus. You are going to write. So that will be 1 over R2, then plus 1 over R3. This one is having plus before, so you have to multiply it minus. Here rather minus. It's going to be, so we just write minus there. Or I think everything is minus already. All the V2 we have are minus, so we just use plus for everything. Because when you times it out back, it should give you minus. So 1 over R4. Then our V3, do we have V3? Yes, we have V3. So V3 is plus V3 into bracket 1 over R2 is equals to 0. So this is node 2. This is node 2 here. Node 2. So for node 1, I'll just drop out the board and begin node 1. As you can see now, do we have any common yes, we have V1. So if I use my V1 to factorize outside the two brackets, 1 over R4 plus 1 over R5. If multiply this together outside the minus bracket plus bracket 1 over R4. So this is V1. Now that we have V3 into brackets 1 over R1 plus 1 over R2 plus V square and V2 1 over R2 for node 2. Node 2, what do we have there? We have minus 1 over R4 minus V2 1 over R2 plus 1 over R3 plus 1 over R4 plus V3 into bracket 1 over R2 is equals to 0. So then for node 1, what we got not quite long now. That one is minus V1 into brackets 1 over R4 plus 1 over R5 and plus V2 over R4 is equals to 0. This should be 1 over R4. 1 over R4 is equals to 0. So now we are bringing it into the matrix without wasting our time. So here now we have V1, V2 and V3. So for the result of V1 we have minus I, and they've given us in the question using Cramer's rule. This is using Cramer's rule. So in Cramer's rule they said I1 R1 rather, R1 is equals to R3 is equals to R5. Then those three will equals to 1 is this ohm. Then the others R2 is equals to R4. Those one will be 2. It's just like other label. Then the current source is 4 ampere. 4 ampere. So that's just it. So we are not having a bigger board. You'll have time to divide the board into spaces. So what do we do now? You are picking the V1, V2, V3 into the matrix. So do we have any V1 here in the equation? So do we have V1? Don't have any V1. So that would be 0. A 0 here. So V2, we have 1 over R2. And what is R2? R2 is 2. So 1 over R2, 1 over 2. For this V2. For V3, we have minus 1 over 1. It will be minus into bracket 1 over 1 plus 1 over R2. What's R2? 1 over 2. So what will that be? That will be minus 3 over 2. Minus 3 over 2. Yes. Then you are done for the node 3. You come to node 2. The V1 here is 1 over what? 1 over 2 because R4 is 2. You have 1 over 2 here. Then minus into brackets. We have 1 over R2 plus 1 over R3 plus 1 over R4 here. So that will be 1 over 2 plus 1 over 1 plus 1 over 2. What will that give us? So it's minus 2. We have minus 2 here. Minus 2. So for here, V3 is 1 over 2. So 1 over 2. 1 over 2. So that's for that one. So we are through with node 2. For node 1, the last one, you have V1. Yes, we have V1. And that's minus into brackets 1 over 2 plus 1 over 1. And that should give us minus 3 over 2 here. And after that, we have V2. That's 1 over 2. Because R4 is 2 here. So it's 1 over 2 for V2. We don't have any V3 here, so put 0. So the results, this one was minus I, and minus I is what? Minus 4. So the rest, it was 0 that was their results. So now that we have our matrix, this is delta. So we are calculating for the voltage rather. Voltage 1, I'm going to calculate for voltage 1, voltage 2, and voltage 3. How do you do that? You have a delta 1 over theta. Voltage 2 will be delta 2 over theta. And voltage 3 will be delta 3 over theta. In the next video, we are going to be picking this delta and delta. How we are going to be getting this delta is very, very simple. No, we already have delta. This is delta. This matrix is the delta. So when you want to calculate for delta 1, you pick this 1 by 3 matrix and come and insert it here in this first row. That will be your delta 1. For delta 2, you pick this same 1 by 3 matrix. You come and put it here and solve for it, this second row, and leave the remaining one like that. So you solve for that, that will be delta 2. For the delta 3, you come and pick this 1 by 3 matrix and place it at this last row here. That will be the delta 3. Solve for it. So when you get your answers, the determinants, you will now be using it to get your V1. So your delta 1 will divide the delta. Remember, I'm going to first solve for the normal delta first. So before you start inserting. Thank you very much. Like and share, comment, and also we are going to be doing the part. This is just part 1 of this. I'm going to be doing the second video very soon. Thank you very much.